Hi everyone, my name is Kemi. I'm a robotics engineer, also an instructor with Born Robotics Educational Solution. Born Robotics is Nigeria's first company in developing educational robots to promote STEM-based robotics learning. Today we will be talking about the Robofest competition robot kit. This year's theme for Robofest game category is binary numbers and box manipulation. Our robot here has been built to accomplish the missions. Let's take the 4 blocks of our robot one after the other. Now we're starting from our control system. This part is our control system. This part here comprises of our control system. This is a motherboard, and here we are using BR3 version. That's BR version 3. That's what we are using here. And we have a microcontroller, Arduino microcontroller. We have different microcontroller. We have Arduino Nano, we have Arduino Uno. But here we'll be using our Arduino Nano. And our Arduino Nano is having a port. This port, we're using our USB to connect the port, the Arduino, to a computer to input whatever task we want our robot to carry out. That is that for our control system. Now to our mechanical system. This part is a mechanical system. These are wheels, our motors. We have 4 motors here. Each motor is attached to a wheel, and we have our pusher. Our pusher will be pushing the box round the board. Then to a sensor. Our robot is using 2 sensors, ultrasonic sensor and infrared sensor. These are ultrasonic sensor. The ultrasonic sensor here we use it to detect. We'll be using it here to detect an obstacle in front of our robot. While the infrared sensor here, we'll be using it to detect the edges of the board, so to prevent our robot from falling off. Lastly, our power supply. Here is our power supply, and we are using 2 LiPo battery to power our robots. So that is all about the components. Now I will be introducing you to a game field. This is a game field. The dimension is 182 by 75 centimeter. So here the length is 182 centimeter and the width is 75 centimeter. And our game field has 2 zones. We have the starting zone and the end zone. So our robot will be starting here from the start zone and ends here. We'll be manipulating our box to the end zone. And we'll be using a box in this game. These are the boxes. We're using 4 boxes for this game. So our robot will be manipulating 4 boxes. It will move the boxes from here to the end zone. So when our robot starts from the start zone, it moves here. Let me make an illustration. Manipulate this box, push it to the end zone. Like I said, the end zone has 4 columns, so we're using 4 boxes actually for the game. The game is an autonomous mission. That is, the robot will be manipulating the boxes from the start zone to the end zone without human interference. Let me introduce you to the competition boxes. We'll be using 4 boxes for this competition. But the 2 of the boxes are unknown factor, which will be reviewed on the competition day. The 2 unknown factors are the position of the 2 boxes on the game field. So this represents box A and this represents box B. So the expected position for box A is between 3 cm to 5 cm from the edge and 35 cm to 50 cm from the end point. Likewise for box B, 3 cm to 5 cm from edge, and also 35 cm here to 90 cm from the edge point. For the 2 open missions, box C and D, the player will be the one to place the box in front of the pusher for the robot to manipulate it to the end zone. Please ensure that your robot your part of your robot and your box are all behind the starting line here. So this is the complete mission of our robot. I'll be showing you how to control and how to make our robot work, how to code our robot, to instruct our robot. So what we're going to need is a USB cable. We have a robot here and a computer. You power your robot, your USB, you fix your USB cable into the Arduino port. Immediately you do that, you will see a light up. That our motherboard, our board is light, is up. Our Arduino is on, it's powered. Our infrared here, infrared sensor is also powered. So that means there's power supply into our robot. So then we can start our coding. Then we have to note this when we are working on a robot, when we're coding, that you always make sure your robot is switched off. There's a switch here, so you make sure it's off when you're programming. So after you're programming, you can remove the USB cable, and when you want to run your code, you put it on. Just make sure when you are coding, the robot is at off state. The only thing the USB is doing is to power the microcontroller, the control system, just so that you can input your code. So let's go into the coding proper.
Alright, so we're going to go through how to use MBlock to program our robot. MBlock is the programming language, is the coding platform we are going to be using to write codes for our robot. First of all, if you have MBlock installed, just right click and then open MBlock to start your program. So when MBlock is open, you can maximize to get a better view of how the program works. Now MBlock is made up of the menu bars, the display section, or what we call in Scratch, this is called the background, and you have here, you select your sprites and your scripting section as well. This is the coding section where you write your code. Now if you are very conversant with Scratch, MBlock is very similar to Scratch. As you can see, the only difference between MBlock and Scratch is that it has an extra block of code here called robot. Now robot section contains blocks of code that we will be able to write programs and codes that our microcontroller, which is the Arduino, can understand. Okay, now to do that, we will go through every section of the menu and what it contains. Now you need to first of all connect your Arduino through the USB port to your computer, any available USB port on your computer, and then you need to do what we call software connection. You will go to connect here, click on connect, and then serial port, and the first COM port that appears. When you click on it, notice something. Before you click on it, notice this red dot here. This red dot here shows you the connection status. It's red because our Arduino is not yet connected. Once it becomes connected, it turns to green. Okay, so to connect our Arduino to the coding platform, you go to connect, you click on serial port, and then the first COM port, you click on it, and then it turns green, telling you that you are okay. That means it's connected. Now that's for how to connect the Arduino to the platform. Other section, you have file. File will enable you to create a new project. You load an old project, or you save your ongoing project, or an ongoing project you want to edit for something else, you can use save as with under file. And then you also have edit. You have edit, you have the boards, you have the extensions, language, and help, of course, help. So edit contains blocks and settings that will enable you to do your normal functions you do on Scratch. Boards is a very important section you should look at for. The microcontroller on our present robot that we are using is called Arduino Nano. So please ensure that Arduino Nano is checked each time you want to write a code. And also you have other Arduino boards available for use. That means you can use MBlock on various other platforms as well. Now that wraps it up for overview of MBlock. Now, to run a sample code, a sample box manipulation program, we are going to create a simple box manipulation program using MBlock as well. Now, every one of you should have a folder called Robofest Games. Just open the folder, and then every one of you should have a folder called Robofest Games. Click and open the folder to access some default programs that were sent to you. Now, one of the programs is Default Robot Mission. Always ensure you start every new project with this file. We've created certain blocks that will make your coding and programming easier and much faster, contained inside the Default Robot Mission MBlock file. So click on it to always start your project with it. Because the MBlock environment is usually assumes that you are doing bare Arduino programming. So therefore, it doesn't really know that you are using the Arduino as a robot this time. But we created this file to enable you use it more of as a robot. Okay, now we have certain blocks of code in our robot section that we'll be working with. And if you are used to Scratch, you have the events block of codes, the control, the sensing, motion, loops, and word of view. So majorly in our robot project, we'll be using majorly control, events, robots, and data and blocks. Under data and blocks, we've created these new blocks for you to be able to run your projects, your robot programming projects with it. So now let's say, for example, we want our robot to carry the box, move a bit forward, say 50 centimeters forward with the box, turn, take a 90 degrees right turn, move another 50 centimeters, stops, places the box, then reverses back and stop. So how do we run that kind of code? What we just do is to always start your program with Arduino program. Arduino program should always be the entry point of your code. So you go to Arduino program, drag it out. Every new code you write must always and should always start with Arduino program, because the MBlock environment sees that you are communicating with an Arduino microcontroller. Then you go to data and blocks, where we've created certain blocks and certain blocks that will make your program easier. If you want the robot to move forward, you use the forward block. Forward block has two parameters. The first parameter is to control the speed, the PWM speed. The second parameter is to specify the time you want it to move forward. The next is backward, the same thing, the speed and the time. Right, Speed and time is what determines the angle of turning. Left, stop, and then there are three sensors, or basically two sensors on our robot. Two edge sensors, left and right and left edge sensors, and a proximity sensor, or a object distance sensor that your robot uses to detect objects in front of it, to calculate the distance between the robot and the object. Now, if we want the robot to move forward, we will drag out the forward block and stack it below the Arduino program. Now, let's say we don't want our robot to move forward, because after we finish writing our code, we are going to download the program onto the Arduino microcontroller, which is on our robot. Now, immediately you switch it on, the program starts running. Let's say we want to put a delay before the program starts running, so we will use wait and put it under before you start moving forward. You use wait so that your robot will, after you switch it on, it waits for 1 second before it starts moving forward. Now we set the PWM speed. The PWM speed is between 0 and 255. 0 and 255. 255 is the highest PWM speed you can set your robot to move. If you set it any speed higher than 255, the platform will always reset it back to 255, because 255 is the highest speed that the robot can take. So let's not use the maximum speed this time. Let's use about a PWM speed of 150 to move forward. And then we want it to move forward. For it to move forward for 50 centimeters, we've been able to come up with certain values for speed and time. And then we discovered that for it to move forward for 50 centimeters, the PWM speed, the time it will take with that PWM speed is about 0.5 seconds. So after 0.5 seconds, you want the robot to stop. So we go back to data and blocks and then drag out stop. Stop will shut down all robot motion whenever you put in stop. So the next thing it does is to stop. Now, when it stops, how long do you want it to stop? You will now need to put a wait behind after the stop. So you go to control, drag out wait. Let's say you want it to wait for another 1 second. After it waits, you want it to turn right. So you go to data and blocks, click on drag out turn right and stack it under. Now you set the PWM speed to 100 and turning time to 0.38. Again, we did a default calculation and discovered that based on our board surface, 0.38 is a very good turning time for 90 to achieve 90 degrees. After it turns for 90 degrees, we also tell it to stop. If you don't put stop, it will just keep turning along the right axis. So it stops, or we can also remove the stop if you don't want it to stop. We want it to, after it turns, it should just move forward after turning. So we can just put forward again, 150, and then we want it to move for another 0.5 seconds, and then we move for that 0.5 seconds. This time around, it has moved for the 150 along the right, and then it should stop. After it stops, we go and put the time it should stop, which is 1 second, after which we would now ask it to move backward, because this time around it has placed the box. We should move backward. We should move backward with a speed of 150, and should move backward for 0.5 seconds. That is another 50 centimeters, and then finally you stop. Now remember, you can always add comments to your program to understand what you're doing. So after I move forward, after stopping, you can right click. To add comments, you right click and then you see add comment. To add comments, so I will say box should remain here. So box should remain here is my comment that I've added. So you can see box should remain here as a comment. You can always add comments to your programs. Now after you finish writing your code, click on robot to know if your Arduino is connected or not. Remember, you must always connect before you do that. So first of all, before you upload your code to your microcontroller, you go to boards, ensure that Arduino Nano is selected. Arduino Nano is the microcontroller we are using on our robot. Then go to connect, click on serial port, and click the first COM port available. And of course, it will now show you that it's okay, you are connected. To connect to download the code, you take your mouse to Arduino program, you right click and you see options. Click on the option upload to Arduino, and then you see this comes up here. What happens is that MBlock converted our entire program, Scratch-based program, to text-based codes. What you're seeing on the right here is text-based codes in C language, and then that's the beauty of MBlock. And with this, you can be learning pari passu C programming language. So all you need to do, MBlock has already converted it for us. This is the code in C language, about 130 lines of code. That's what we did in these few blocks we just stacked together now. And then you simply, since it's already connected, you click on upload to Arduino and then wait for the program that has been converted to be uploaded to our microcontroller. You just wait a little bit while it is establishing communication with the microcontroller, and then it will be showing you uploading. So at this time, you don't do anything, you just wait for the program to be uploaded. When it finishes uploading, it has finished uploading now, it will now change to upload finish. Now upload is finished, you click on close and then you detach your Arduino from the USB. So that wraps up our section for how to program your robots with the MBlock programming environment. Thank you very much.
Our code is successfully uploaded on the robot. So let's explore the robot and see how it works. You place your box in front of the pusher. You put it on, switch on here. Here, our robots are successfully carried out the mission and our code is successfully test run. Now that ends the Robofest game mission. Thank you. I remain Kemi, your robotics instructor. Bye.